exponent laws. And again, Charlie's a very intrigued student in our lesson. So there's 3 exponent laws, and this is probably brand new to you. And I'm going to show you what they are and how to use them. And this is going to lead to some very difficult looking questions, but actually they're not that hard. And I hope you, like I do, I hope you have a little bit of fun with them. Okay, first rule we're going to learn, is called the product rule. And it just says that if you have, this is supposed to be a generic example, okay, where you have just letters. So I'm going to show you the letter example, then I'll show you a number example. So if you have some number, we're going to represent it with a letter, A, to the exponent B, times the same number, but to a different exponent. And that's really important to get. Same bottom, same base, but different exponents, or same exponents, that's not important. But if you were to have that expression, it works out to a to the b plus c. And what I mean by that is if you had 2 cubed times 2 squared is the same as 2 to the 3 plus 2, which is 2 to the 5. And just if we do that math in our head, 2 to the 5 is 2 times 2 is 4 times 2 is 8 times 2 is 16 times 16 times 2 is 32. So this is 32, right? All right, 2 cubed is 8. Times 2 squared, which is 4. 8 times 4 is 32. So they're the same thing. They mean the same thing. It's just different ways of saying it. And if we want to simplify an expression, you're going to take it from, something big like this, like here, and make it into one single product. Sometimes the question will say express as a single, here it is, express as a single power. Okay, so let's do some examples. That's supposed to be a 7. Hope you can read yours. But if you had 2 to the 4 times 2 to the 7, and it says to express as a single power, you say, okay, that must be 2 to the 4 plus 7, which is 11. Okay? All I'm doing then is just making this a simpler term. Same here, 2 to the 3, now just times 2. That looks tough, but you just have to remember that 2 is the same as 2 to the 1. 2 to the exponent 1 just means 2 times itself once, which is just 2. Okay? So that means you got 2 to the 3 times 2 to the 1, which is 2 to the 3 plus 1, which is 4. Okay? And it doesn't have to be 2, it could be a decimal. It doesn't change anything. This time our base is minus 0.4. To the 3, I hope yours is easier to read than this, and times minus 0.4 to the exponent 2. And so without all the steps, you start to realize it's an easy pattern. 3 and 2, and you have to add them. So you get 5. Okay? So 3 plus 2. Okay, this example I put in for a very, very, very important reason. 4 squared times 5, 6. You can't express as a single power because they have a different base. Okay? If the base is different, then you can evaluate it, but you can't express it as a single power. So you could put that in your calculator and say that's 4 squared times whatever 5 to the exponent of 6 is. I don't know that in my head. But you could put in your calculator and get an answer. You can evaluate it. But when it says express as a single power, you cannot. Okay, so that's the product rule. Quotient rule is very, very similar. Remember, the quotient rule is quotient means divide. So it's either a fraction or it'll look like this. Okay, either way, again, this is the generic rule. It's equal to whatever the base is to the exponent b minus c, the numerator minus the denominator. Okay. Just to give you a number example for the same thing, 2 cubed over 2 squared is 2 to the 3 minus 2. Right? 3 take away 2, that's the quotient rule. And 3 minus 2 is 1. 2 to the exponent 1 is just 2. And again, to redo that math in our head, 2 cubed is 8. 2 times 2 times 2. Divided by 2 squared, which is 4. 8 divided by 4 is 2. Okay? Again, I'm rushing to the next one, but of course you can pause and catch up with your writing. So a simple example, 2 to the exponent 6 divided by 2 to the exponent 4, again, is still 2 at the base, and you just subtract. 6 minus 4 is 2. Another one, 5 exponent 4 over just 5. Remember that just 5 means 5 to the exponent 1, so it's 5 cubed. So anytime it says express as a single power, that's what I'm looking for. I'm not looking for you to put it in your calculator and figure out what the number is, because sometimes it's not a number. Sometimes it's a x. It's a variable. And, usually x, but it could be z, it could be m, it doesn't matter. Same rule. So, but you still do the exact same thing, right? X cubed over x squared. Well, the base, you write the base, and then the exponent is this minus this. Okay? And x to the 1 or just x, whichever one. Doesn't matter, they're both correct. All right, power rule. Third rule. This is if you have a number that's to the power. So a to the b to the c. Sounds like a song. A to the b to the c is equal to a to the b times c. So again, looking at that as a number. 2 squared, all to the exponent 3, is 2 to the 2 times 3, which is 2 to the 6. Okay? So anytime you have a power to it, like you might word that as power to a power. It might be the way that you say that. Okay, this example expresses a single power then. 3 to the 2 to the 4, right? So again, all it just means is 3 to the 2 times 4, which is 8. Again, single power is just one exponent. Okay? All right, you ready for this? Ready for a big one? This example, by the way, hopefully you get where it starts and finishes. I didn't do a very good job of it. It kind of goes like that, okay? So this example, I'll solve it over here. I didn't leave enough room, sorry for that. All right, so here we have a bunch of letters, well, 2 anyway, an x and a y. There are variables. X is squared and y is not. And then it's all to the power 3. So we have a few things going on there. First of all, to do this question, you need to identify the fact that y to the nothing is written. It's implying that it's y to the power 1. Okay, so I rewrote this. Really, this is the exact same thing. It's just putting the 1 here, or 1 right here. Okay, now, similar to when we had a fraction all to a power, it's kind of the same thing. You have to kind of distribute the 3 right through. So that works out to x to the 2 times 3. You have to treat the x and the y completely separate because you can't do anything with the x and y. Like I say, you have to do brackets first, but you can't simplify this anymore. You can't x and y, you can't make them any more the same thing. So you can distribute the 3 through. So 2 times 3 is 6, right? So that means x to the 6. And y becomes 1 times 3, which is 3. I wanted to say 4 there, which is a common mistake. Okay? So you just keep the x and y and do what you can. Okay, so let's look at this one. What I tried to do on this one down here is the times. I wrote in green. Okay, I just did that so you didn't confuse the times and the x. It's sort of an unfortunate thing along the way that x became this most popular variable in math when it looks just like a times symbol. Anyway, so the first thing I did was only rewrite the same line, just putting the 1 there. That's all I've done, right? X squared y is x squared y the 1. Okay, other than that, exact same line. The next line down here, I've distributed the 3. Okay, this is similar to the question above, right? So if I distribute the 3, then this 6 is just the 2 times the 3, and this 3 is the 1 times the 3. And over here, I haven't changed anything yet. Okay, next line, because, even I got the bracket here, and I had the bracket here, like you can't simplify them anymore, but because now I've gotten rid of the exponent, I can separate these. I can kind of get rid of the bracket, right, and just say that, I just write it all as a big multiply, and I've put the x's beside each other, right, and I'm going to put the y's beside each other, because if you can multiply, it's like saying 3 times 2 is the same as 2 times 3. You can switch things around when you're multiplying. You can just put them wherever, as long as they're all multiplied. Okay, so this is this is this, the y cubed is right here, and the y squared is right here. Okay, I'm just separating them out. Now I've got x to the 6 times x to the 4. Use the power rule, the product rule to get x to the 10. And same with the y's. 3 plus 2 is 5. Okay, and then there's my simplified expression. One more, and she's a doozy. Okay? This looks big, but you know what? When you practice these, they're not very hard. They're not very hard when after you've practiced a few times. So, and this is our last example. So now I've got this x squared y, all exponent 5, and then it's multiplied by x squared y squared with no exponent, or exponent 1 if you will, divided by xy to the 4. So the first thing, again, is I can't simplify inside the brackets anymore, right? I can't do anything there, so I'm going to do the exponent next, bracket exponent. So power rule says that this must be 10, right? So I'm distributing the 5 through, it's right here. So now I've got x to the 10, which is 2 times 5, and y to the 5, because that's y to the 1 times 5 is what I've done right here. Okay, and I have my times, and I have x squared, y squared, so this hasn't changed and this hasn't changed. All I've done is taken care of this part. Now, what happened here is a big step, but all I'm saying is I'm collecting sort of all the x's and I'm using my product rule because everything up here is now multiplied, right? So x to the 10 times x squared is x to the 12. I'm adding my exponents. And then I've got my y's and I add my exponents. And then I've got x to the 1 on the bottom, xy to the 4. I haven't changed that at all. I'm just writing the 1 in. Excuse me. Now I use the quotient rule. X to the 12 minus 1 is x to 11. X to the 7 minus 4 is x to the 3. And that's as simplified as I can get. So that looks like a huge question, right? Looks huge. But when you can break it down and make it look into something very simple. And you'll definitely have some time in class to practice that skill. And make note of any questions you have for me, and I'll talk to you one-on-one in class.